Sorry, I forgot to let you know at the end of the last video to grab your vocab sheet. So if you want to pull that up now, go ahead and pause the video for a second. The next part that we're going to learn is composition of functions. This is when you take one function and you put it into another function for x. So we've seen the function notation, we've seen replacing x with some expressions, and if you think back to the difference quotient when we learned that, we were composing functions. We would put something like x plus h in for x. So you could think about x plus h as your g function, and you're putting it into the f function for x. This again has two different notations. I really like this notation, and as you can see from my diagram, it makes a whole lot more sense. You start on the inside and substitute until you get to the outside. This, called the fog notation, means the same thing, but I don't think it's as obvious what you are supposed to do. Again, you've got to be familiar with the notation, but the first notation, you start with x, put it into the g function, but you then put that whole thing into the f function. So I like the visual aspect of that notation. So let's see how this works. We're going to start with a couple of functions, and we're going to also take a look at the domain. So starting with the g function, take the entire g function. Look how that is going to replace the f in our f function. So we're going to put the whole g function right here in for x. Now the g function isn't g of x, it's 3x. So that's the expression that we'll actually be using. So f of g of x is going to become f of 3x. So notice how I replaced the g of x notation with the function 3x. Now I'm going to replace the f notation with the function 3x. Putting that into the f function, that x squared minus 1 function for x. Simplifying this, we'll get 9x squared minus 1. The domain for both the f and the g function are all real numbers. Same for our composition. All right, so the next one has our fog notation, f of g of 4. Well, we've already found the f of g function, so we can just take that 9x squared minus 1 and substitute 4 for x. So because 9 times 4 squared minus 1, 9 times 16 minus 1, which gives us 143. This time we're going to see a square root and a square function. So when we get to the domain, it'll be a little bit different. So we're going to start by putting this whole f of x function into the g function. So I'm going to do this a piece at a time, and I'm going to replace my fog, or in this case Goff notation, with the g of f of x notation. And I'm going to start by replacing the f of x with the function square root of x minus 1. And now I'm going to take that whole expression, all of the square root of x minus 1, and replace the x in the g function with that expression. So it becomes square root of x minus 1 squared plus 1. The square root and the square cancel each other out, so we get x minus 1 plus 1, which simplifies to x. Now looking at our g of f of x function, we have x. Well, that's all real numbers. However, it came from first putting values into the f of x function. So we do have a domain restriction on this one, and that's what's under the radical has to be greater than or equal to 0. Adding 1 to both sides, our domain is x has to be greater than or equal to 1. So when we take a look at part B and we're asked to evaluate g of f of negative 2, well, we just looked at the domain. Negative 2 is not greater than or equal to negative 1, so we cannot evaluate the composition at negative 2. It's undefined. And here are your you try problems.